Hello everybody, this is Mr. Storm. In this video, we are going to talk about some other object-oriented programming relationships that we can have with our classes. So let's just jump right into it. So first, let's talk about encapsulation. Encapsulation means basically you can hide sensitive data from your users. So in order to do this, you have to set some variables to private, but the problem is whenever we create private variables, they become inaccessible by other classes unless we do something very specific. So let's talk about how this works. So let's say I created a new class here, and the class was called person. And inside this person class, I had a private string name, right? And let's give that string name a value of David. Okay. Now up here in my main class, maybe I want to instantiate that person class. So person, my person equals new person. Oh, person. There we go. All right. So I've instantiated it now. Now I should be able to just say system.out.print line, my person.name, right? You would expect it to work that way because I'm instantiating that class and I'm accessing name, but notice we have an error here, and it says the person.name is not visible. If I were to run it, I get an issue here. It'll tell me, hey, we don't have private access to that variable, right? So in order to do that, what I would need is I would need something called a getter. The getter is basically a new method. It's a custom method inside of this class. We're going to create it as a public method, and it's a string because I'm going to return a string. We'll say get name. We'll just create a new method called get name. And then inside, we're going to say return name. Okay. Now up here, instead of saying I want to output my person.name, we can say I want to output my person.get name, right? So I want to run that method get name instead of trying to output just the value of the variable. Notice that it's still a private variable, but I should still get my desired output that I'm looking for. And I do right there. Now, let's say I want to set the value of this variable to something different. Well, for that, we would need something called a setter. Setters are actually really easy. Let me put a comment in here so that we know what this is. This is the getter. Sorry if you're hearing some background noise. My wife and my daughter are watching a horror movie in the other room, so you might hear some screaming and explosions and stuff. But we're doing something way more exciting. We're talking about getters and setters in Java. All right, so the setter is just another method as well. So public void, because we're not going to return anything. We're just changing the value of a variable. Set name, and we're going to bring in an argument, and this argument will be called new name. And we're going to set this dot name, meaning, so the this keyword refers to this specific class, right? So this class, this object, this thing that we're inside. So this dot name is going to be equal to new name. Okay. Alrighty. And then what I can do is I can actually set, let's do my person dot set name. So set name. And the new name that I want to set it to is Bianca. I don't know how to spell Bianca, so Blaze. I don't know. Let's go ahead and run it. We should get Blaze instead of David because we're setting the value in our set name. Hey, there we go. We're setting the value of this variable using our setter. Okay, so that's setters and getters. Again, this is really only relevant if you're using private variables, but you should, for the most part, this is a security issue, so most programmers will use private variables in their public classes, and they'll use getters and setters to change the values of those variables. It also helps you to control your variables a little bit more, because if you use them, the private keyword, and you don't give them a setter, then they can't change the value of that variable. Okay. Let's talk about packages real quick. So in Computer Programming 1, we used one package really often, and it was the scanner package. That was a special package that we had to import into Java or into our project to use it, right? Scanner. And we did this often because we wanted to be able to use the scanner's features, which is, reading what our user has typed and then storing it in variables. So I would create I would import it, then I'd create an instance of it, scanner. We always called it reader equals new scanner with an argument of system.in. And then what I could do is I could say, I don't know, system.out.print line. What is, I need quotes there. What is your name? And then I'm going to make it a print. And say string user name equals reader dot next line. And then instead of sending it the value of Blaze, we'll say user name. And we have to make sure we close our reader. Okay. So let's run that. Come on. All right, so what is your name? My name is Greg. And then it outputs Greg. So this package here is something we're familiar with. We've used this plenty of times in the past. You can create you can create your own custom packages if you want, which we're not really going to get into, but it's just like creating a class. You would create a package file or a Java file, a .java file, and you would indicate with a keyword package, and then you would give it a name. And then whatever you want to put inside there, you can put inside there. So classes, methods, you name it, right? One thing that we can also do is, let's say we want to use a lot of packages inside the util folder. If we use an asterisk instead of indicating the package by name, notice that it gives us a bunch of the packages that are already in there. We have abstract, class, enum, final import, interface, non-sealed, public record, blah, 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 all this other stuff, right? We can import all of those packages in at once without having to without having to specify them by name. All right, that is packages. Let's talk about inheritance real quick. So inheritance is the concept that classes can be related to one another in a very specific way. You can have a subclass, which is the child. The child, or the subclass, can inherit all of the methods and variables from the parent or the superclass. So if I create a parent, for example, let's just create one real quick. Let's create we can use the example in the lesson. If I were to create, let's just get rid of that. We don't need that anymore. We don't need any of that. Let's get rid of all that. And we don't need these classes either. Let's create a class called vehicle. Pretty easy. Vehicle. And we'll say public string brand equals Ford, right? And then we'll give it a public method as well. Public void honk. And we'll say system my.out.print line toot 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 toot. Right, so we're honking the horn. So this class right here is called vehicle, right? Now, if I wanted to create a special kind of vehicle, meaning instead of being just a Ford, I wanted to indicate maybe something more specific that could access this stuff, but also could have its own values and variables. I can create another class, call it car, and I'll say extends vehicle. What that means is anytime I access this car class, I will also be accessing vehicle, right? So I'll have access to this variable brand and this method honk because I'm extending that vehicle class. And in here, I'll just give it let's make a public string, and I'll say model name equals Mustang. Okay. So now I have two separate classes, vehicle and car. And let's say in my main, let's instantiate just one of them. I'm just going to instantiate car. There's no need for me to instantiate vehicle because car already extends vehicle, right? So I'm going to instantiate car. Car, my car equals new car. Okay. So I've created a new instance of car, which also extends vehicle. So I've grabbed vehicle as well. And to prove that, let's go ahead and access this honk method. So my car.honk. If everything worked, if the relationship here worked, then what I've done is I've created an instance of this class called my car. But this class also extends this class, meaning I can access this method without having to instantiate the vehicle class. So let's run it and see if that worked. And it's taking quite a while. Come on. Then almost. There we go. Toot toot, it says. So I've been able to access that method outside of the class, the direct class that I instantiated. Let's see. Let's put a string on let's say system.out.print line, and we'll say my car dot brand, which is also a variable inside the vehicle class, plus, and we'll say my car dot model name. All right. So that should say toot toot Ford Mustang, if everything is correct, which it is, or at least it should be. I'm still getting these random weird variables that are popping up and not variables, but these errors that are popping up and not going away. But we did it correctly. Toot toot Ford Mustang. Beautiful. Okay, so the last thing we need to talk about here is polymorphism. Okay, now polymorphism is a concept in programming that essentially just means many forms. Poly meaning many, morph meaning forms. So polymorphism, many forms. And really what that means is that we can have classes that are related to each other by inheritance, and that inheritance allows us to pass values down to the children. So parents pass values to children, but we can perform a single action in specific ways. So for example, let's say that we had, let's just create the example. Let's just do it. So it may make it a little bit easier. And by the way, from here until the end of the video, this is the actual assignment that I want you to perform. I'm going to do part of it. You're going to do the rest. So I'm going to just delete my classes for that example, and we'll go back up to having an empty main class. All right, let's create a class called animal. class animal. This is going to be our parent class for the other classes we're going to create. We'll create a public void animal sound. Oh, hello. Sound method. And we'll say animal sound system.out.print line. This animal makes a sound, right? Most animals make sounds. So this is a pretty good statement to put out for any animal, right? We can call the sound that the animal makes. We'll just say this animal makes a sound, right? Now, this method by itself can be different depending on the class and how we use it. So let's see what this would look like for example, a pig. Class pig extends. I was thinking extends in my brain because I was about to say the word, and then I put the X at the end. Anyway, animal. So we want to access that animal class. So pig extends animal. And we can create another public void animal sound. Now, you might be thinking, wait a second. If we're extending this animal class, then it already has an animal sound. Isn't this going to cause issues? No, because this is a very specific version of the animal sound class. This is what polymorphism means. There are many forms to this one variable or this one method. You can create a method in many different forms based on the class that it's in. So in this specific animal sound, it would be system.out.print line. The pig says oink, oink, right? Okay, perfect. Let's create another one. Let's create a dog. And actually, I can just copy and paste. Copy, paste, and we'll say class dog extends animal. And we'll say the dog says wolf, wolf. All right. So we have 3 versions of this animal sound method now. And notice when I access one of them or when I highlight one, it actually highlights the others because it recognizes that they're the same. So in my main method here, if I instantiate all of those, so animal, and we'll say my animal equals new animal. I can output that dot animal sound. So I can output that animal sound onto the hello. There we go. I can output the value of this method animal sound onto the console. And it says this animal makes a sound. But if instead I were to instantiate my pig animal, my pig equals new pig, and then I was to say my pig dot animal sound, it would be a different message than this one, even though we're accessing the same things. The pig says oink. Did I give it? Oh, I did give it some space there. That's weird. And notice that I used animal instead of pig. Either way is fine. I could do, let's say, pig dot new pig and run it, and it's fine because I'm extending this animal class. Then I can create a new version of pig, or I can create a new version of animal and call it pig. But either way, they're related, right? So then I can do the same thing here. Let's say dog, my dog equals new dog, and my dog dot animal sound, and run it. And at some point, it's going to, there we go. So the animal makes a sound, the pig says oink oink, the dog says wolf wolf, right? Now, this may not seem like it's really super important here, but one of the reasons why we would use polymorphism is, let's say, for example, you had a video game, and there was a class called enemy, and you had a method called deal damage, right? And you had a slime enemy that inherited that enemy class, and its deal damage method might have different values than, let's say, a giant dragon, right? It's still an enemy, it's still in the same category, but we want it to be able to do different things, right? So this is the concept of polymorphism. So we've talked about inheritance, polymorphism, we talked a little bit about packages, getters and setters for private variables. At this point, we've learned so much about object-oriented programming, we can actually start moving into bigger projects that use these concepts here pretty soon. We're getting close to being able to move past theory and actually build some cool stuff. So here's what I want you to do for this assignment. I want you to create basically what I just created here. Create a program that has an animal class, and then create a bunch of extra animals that extend that class and changes the value of, let's say, a method. You can even just copy what I've done here, add a couple more animals to it, like sheep or cat or whatever, and then show that you can actually create different outputs even when calling the same method because of polymorphism. Okay, perfect. Thank you for paying attention, and I will see you next time.